So my question is number 22, which asks us to provide two different growth functions that models the figures below and describe how each function relates to the figures geometrically. So here's our four figures. We have figure 1, which has 7 squares, figure 2 has 9, figure 3 has 11, and figure 4 has 13. So a great idea is to always make a table if you have a hard time seeing a pattern between the figure number and the number of squares, or even if you have a hard time seeing any relationship between each of the figure numbers and how many squares are in each of those. So that's what I did down here. We have figure number, which I'm going to be labeling as n through both equations. And then, so figure number 1 has 7 squares, figure number 2, 9, figure 3, 11, figure 4, 13. And in doing so, I noticed that there is a relationship of plus 2 as it goes. So you have 7 plus 2 is 9, 9 plus 2 is 11, 11 plus 2 is 13. So that'll later help us in our equation, or both of the equations actually. So the next step that I take to figure out an equation for figures is to actually look at the figures and see what any similarities they have shape-wise, not the size-wise, but shape-wise. So in the four figures, we have always one middle square in each of these, right here. And that is consistent. So what I noticed is that we have two columns right beside on each side of one square. So the only thing different between the figures is actually the number of squares in each column. So we have 3 squares in this column on figure 1. We have 4 squares in this column on figure 2. We have 5 squares on figure 3. And we have 6 squares on figure 4. Now, notice that it goes up by 1 for each of the figures as it gradually moves to the right. But what you want to look at is what is the relationship between the figure number and the number of squares in each of the column. So between each of it, it's actually a number of 2 difference. So figure 1, 1 plus 2 is 3. Figure 2, 2 plus 2 is 4. Figure 3, 3 plus 2 is 5. And figure 4, 4 plus 2 is 6. So what you can think of, or how you can think of this, is f of x for our equation or function. You have plus 1 always for each of the figures for that lone middle square on each of the figures. So there's our plus 1 for that square. But for the plus 2 for the n, you can write as n plus 2. But realize that that just only counts for each of the columns here. You have 2 equal columns on each figure. So you can easily remedy that by just multiplying it by 2. So that makes our equation of 2 parentheses n plus 2 parentheses plus 1. Now always check your equation, so let's do it for figure 1. So we have 2, and in the parentheses 1 for our figure number, plus 2 plus 1. Now 1 plus 2 is 3, and you're going to multiply that by 2, and that is 6, so 2 times 3 is 6, plus 1 equals 7, which checks out. I'm going to go ahead and do it for the rest of them just to make sure that it is correct for each function, or each figure. So figure 2, So there's our 2 for the n. 2 plus 2 plus the 1. So 2 plus 2 is 4. And we're going to multiply that by 2, which is 8 plus 1 equals 9. So we'll do it for figure 3, which there's our 3 for the figure number. Oops, plus 1. And then, so 3 plus 2 is 5. And we are going to multiply that by the 2, which that's 10 plus 1 equals 11. And then for the last one, for figure 4, there's our 4 for the n, plus 2 plus 1. So we have 6. We're going to multiply that by 2, which is 12, plus 1 equals 13. So it does check out for all of the figures. So our first equation that we found is f of x equals 2 parentheses n plus 2 parentheses plus 1. That right there is our first function. And for geometrically speaking, to describe it, our plus 1 is our lone middle square in each of these. This, in the parentheses, counts as one column right here. So it's n plus 2, because remember, our figure number was just a 2 difference between the figure number and how many actual squares were in one column. So there's that. And of course, since we had 2 columns, we multiplied it by 2. And that is how you explain it geometrically. Now we're going to describe our second function. So, and I wrote right here so we could keep in mind what our first function is, so we didn't forget it. I'm going to erase inside the square since we're going to look at this a little bit differently. Now remember, I kind of broke down what each figure looked like and try to find similarities. So I'm going to do the same thing, but I'm going to try it in a different way. I'm going to use a different color. I'm going to leave this because that's how we looked, or how I looked at the figures the first way. So for the second way, I'm going to take a look and notice that on each of the figures, their bottom is the same, their bottom row, which is these 3 right here. So for this, it has a consistent 3 squares at the end. Okay, now the rest of it is just 2 columns on the edges right there. Now the shape is very similar still, it's just the size that differs. So what I'm going to do now is going to look at how many squares are in each of the columns for each figure for now. So on this one it's 2. We have 3 on figure 2, 4 on figure 3, and then on figure 4 we have 5. Now I didn't count any of the 3 down here. I only counted what was left sitting on top of the 3, the consistent 3 on the bottom here. So after doing so, I noticed that the figure 1 is just plus 1 to get that 2. And it's the same all the way down the row. So figure 2, you have 2 plus 1, and it's 3. Figure 3, just 3 plus 1, and it's 4. And then figure 4 plus 1 is 5 right there. So kind of the same thing. We're going to write out our function f of x here. Now since I first started with the plus 3, or the 3 consistently on here, I'm going to do a plus 3 at the end of my equation. Now for the relationship between the figure number and the number of squares on the column that was left over, it was n plus 1. So I'm going to do parentheses right there. But remember, it's only just one column that represents. So to get both columns represented in the function, you need to multiply it by 2. Which, if you notice in both equations, you have 2 being multiplied of something for each column, right here and right here. That is where our plus 2 of relationship between the figure number kicks in. So once you get better at just being able to look at a table and being able to see how you can go about on getting a function, breaking it down is an easier way also. So for our equation, we have f of x equals 2 in parentheses n plus 1 parentheses plus 3. So the plus 3 is that consistent 3 on each figure. The in the parentheses actually represents one column right here. And since we have 2, we're multiplying it by 2 to make sure we represent all of the squares in each figure. So let's go ahead and check it just to make sure it's right. So we'll do it for the first one. So the n will be figure 1. So that's 1 plus the 3. So you have 1 plus 1, that's 2. You're going to multiply that by 2. So 2 times 2 is 4 plus 3 equals 7. That checks out. I'm going to go ahead and go down all of the figures just to make sure it is correct though. So this is figure 2, so it'll be 2 plus 1 in the parentheses, which that would be 3, which you're going to multiply the 3 by 2, which will be 6 plus 3 equals 9. So for figure 3, that's right there. So it'll be 3 plus 1 in the parentheses. So 3 plus 1 is 4, and you're going to multiply that by 2, which you get 8 plus the 3 equals 11. And for figure 4, so it'll be 4 plus 1 in the parentheses, plus the 3 for the consistent 3 squares on the bottom. You have 4 plus 1, which is 5, and you're going to multiply 5 times 2 to get 10 plus the 3 equals 13. So that also checks out. So your second equation is f of x, 2 n plus 1 in the parentheses, and then plus 3. And so those are your 2 equations. Now for the second one, remember the plus 3 is the 3 consistent squares on the bottom that never change the size or shape. Now the in the parentheses represents what's in one column for each figure, and the n is the figure number. So we did figure number plus 1, which ended up being the number of squares in one column. And to get both of the columns represented in the equation, we multiplied it by 2. So there, right there, is both of your equations. Now, if you take a look at it, you can actually see some similarities between them, such as it's both multiplied by 2, which is where our relationship comes from between each of the figures and the number of squares. In that it has the figure number in parentheses plus something, and that it also has a consistent number plus 1. So those are your 2 equations for the 4 figures that we have.